John, you want to be co-host? All right. Hey, Sylvester. Hi. Okay. We got the mixer is mixing, and just do a sound check there for me. Good. Hi, Sylvester.
Hi,
How are you?
I'm good. I'm good. Thank you so much. I'm in Seoul
Okay.
still, and I'm just gonna follow up all the happenings from Seoul.
All right. So, let me make the announcement here. I'm just getting going. It's Tuesday, April 19th, 2016, and this is the Keshe Plasma Reactor Group. My name is Rick Crammond, and as usual, we will have a discussion regarding Keshe things, Keshe experiments, and other questions and different things that will come up here. I think we're going to start maybe. John, do you want to start off with something you were contemplating, and maybe we can work into Vivek after that?
Okay.
Um,
Well, I'd
what
like
were you
you to
talking about there, John?
mine here. Um, since I moved, I have not had a successful GANs setup. It's driving
For
me
some
nuts.
reason, I'm not hearing.
He's not hearing anything.
Okay,
Plug
hang
your
on a
headphones in.
second here.
Hello, Rick.
Yes, my soundflower is not soundflowering, so just a minute
Uh-oh.
here.
That's not good. Yeah, we'll get to you, Lee.
Now I got it.
Get your stuff going.
Oh, I got it. It's very weak, but
Yeah,
I've got
just
it.
getting the cameras all set up. Getting
All
to you.
right, I think I've got it there now.
All right.
Um, Maybe I should go with Lee. What do you got there, Lee? You got something you want to show us? I see your video's on.
I got a Q12 here. Did this week.
Pardon me?
A Q12 cube this week. I did. I just wired it tonight and plugged it in, and the light came on the load side, so it's working. But I can't tell you too much about it.
Okay, well, let's just have a quick look here, I guess. And this is the Cube 12. Is that what you call it?
Yeah, Q12.
Holy cow, look at all the. You
Sorry,
must
that's
have gone
actually
through about a ton of.
24. It's got 24 plasma capacitor batteries on it.
Okay, how many coils are included there?
Yeah, the batteries you mean, or the plasma
Well,
batteries?
you have coils as well, or just plasma batteries?
No, inside I'm using they got aluminum cones all pointing towards the center now.
Oh,
So
right.
it's made stronger. So I got the aluminum cones inside the the 4 inch by 4 inch by 4 inch cube, that glass vase, and then I stuck and I got the cones in there and glued another piece of glass on top, and then put the capacitor batteries all around it.
Holy cow. What a contraption. You must have gone through a lot of hot glue on that thing.
Oh yeah, lots of hot glue. But the
My,
thing is, it doesn't stick to the glass vase very well. So
right.
you're hot gluing everything together.
Yeah.
So it's all hot glued around the glass vase, so it can't come off.
So what does it do when you plug it in and so on? Does it do anything?
Well, I could feel the field around it when I had my hands on it, and I just had a 100-watt light bulb, and when I plugged it in here to tonight about an hour ago or a couple hours ago, then I
Do,
went around and made this wood base on the bottom, which just supports the four corners of the glass vase in there.
do you condition these units to break them in as such, or is it sort of
Yeah, the
all?
guys have been conditioning them, so they condition really fairly fast, but so it's like a week-long process where you add stuff in slowly. So,
I see.
and so, but I'm interested in trying out they're putting a 12-volt car battery with converter on it to run the AC side, and the thing is keeping the battery charged as well as running the load. So I'm going to be experimenting with that this week.
Ah, yes. Okay. Well, good luck with that. We'll get a report next week on that one, I guess.
Yeah, I'll try and get you some results for next week. So
Right on. Well,
anyway,
that'd be interesting if it would power itself that way.
yeah, so it would be. And we'll have a true generator.
Okay. Anything else to report from your end, or?
No, that's it. I just wanted to show off this mass of wires here.
Great. It is incredible mass of wires, isn't it? Is it quite heavy?
No, 5 pounds or something.
Okay. Right on. Okay. Well, we'll hear more about that one for next week then.
Okay.
All right. Who else here would like to do a little show and tell? Vivek, maybe you want to bring in your little
Sure.
presentation.
Okay. What I was working on mentally is a system that would work in a car, not just to enhance the way the car operates, but to also reduce, if not cut, emissions. So let me just do a quick screen share. And this is the system that kind of imagined would work in that way. So is the screen share coming through? Okay. So here we have the Magrav's car unit, and you have the positive of the Magrav's car unit connected to the positive terminal of the battery. The negative terminal that's marked number 2 goes and connects directly to the engine block, because that's where the highest energy draw is. So the idea is to send as much plasma there directly. Then the next connection that we have over here, which is marked number 3, is from the engine block down to this nano mesh that we have over here on the exhaust pipe. Now, the idea is to create a field interaction over here that completely, if possible, negates the use of a catalytic converter and or in modern diesel vehicles, the diesel particulate filter. So it's wrapped around the exhaust pipe before any of these two devices, and it's connected to the Magrav's car unit through an electrical connection through a wire. Then we have a wire that's running out, number 4, that connects to the furthest chassis grounding point from where the Magrav's car unit is connected. So you create a plasma pathway around the car and back to the battery's negative terminal through number 5, which is the car's existing grounding wires that are already on the chassis. So this is an overview of what I was thinking about. As you can see over here, there's the air filter box and the nano mesh, which is standalone with regards to the electrical connection itself, or rather the wire connection, since we're talking about plasma and it's not electrical. Let me just share the next window. So this is kind of the idea that John and I were discussing. And we came up with a GANS mix, not just in the fuel tank, but in the radiator as well. The idea is to create a plasma bubble around and energize not just the fuel that's going into the engine, but the workings of the engine itself, because the radiator flows coolant around the water jacket of the engine, and by flowing GANs through there, we pretty much create plasmification of whatever it is flowing through. So that was one idea that that we came up with. Now, the other thing that we were talking about is how are we going to plasmafy the air that's coming into the engine for better combustion or better rotation of the crankshaft. So the idea that we had is to have two copper meshes which are nano coated, and then to coat the inner copper mesh with CH3 GaNs and the outer with CO2 GaNs, and wrap them around the airbox inlet pipe. So there's no mechanical action here, purely field interaction. And we are thinking that this would create a plasmification of the air that's coming into the engine. Now, in an earlier iteration, I had an electrical wire that connected both copper meshes, but thinking about it over the course of the past 1 week, I figured that that would not be necessary since we are going for pure field interaction. So I removed that connection wire. And this kind of operates on the principle of the health pen. So that's what we are thinking for the airbox inlet pipe. Then we come to the exhaust system. So what we have for the exhaust system is a series of 3 nano-coated copper meshes. The innermost nano-coated copper mesh would be coated with lead GaNs. And as you can see over here, there's a wire that comes from the engine block and connects to that wire mesh. So this acts as a sink to draw in the plasma that's coming from the MagRev's unit and brings it in over here. Now, the second nano-coated mesh has a combination CO2 and CH3 coated onto it. Now, with each subsequent layer, what I was thinking of is that first you have an exhaust wrap wrapped around the exhaust pipe. The innermost one would be soaked in the plasmified water of the lead GaNs. Then you wrap it around the exhaust pipe. Then you apply the nano-coated mesh, which is coated in lead GaNs, onto that exhaust wrap. Then you wrap that in further exhaust wrap, which is soaked in the plasmified water of CO2 and CH3. And then comes the nano-coated mesh of CO2 and CH3 that goes around that. Finally, you have one more exhaust wrap around that, which can also be in the plasmified water of CO2 and CH3. And then finally, we have one more nano mesh only, but this is not coated in GaNs at all. It is just a nano mesh. And to it, we have a copper wire that attaches out and goes to the chassis grounding point. So the idea is to create a toroidal vacuum within the exhaust pipe itself before the catalytic converter. And the idea would have been to take whatever's coming out in the exhaust stream, most notably carbon monoxide, carbon dioxide, and the various noxious gases, turn them into a plasma state in that field interaction, pull them out towards the sink, and send them outward toward the nano mesh only of the outermost layer. And then you send that energy back into the car, where it circulates back to the battery and starts the process all over again. So would like to have comments on this, please, from everyone.
Everybody's speechless.
Everyone's like, what on earth is he talking about?
Speechless in Nova Scotia for sure, watching this going, wow, one day I'll understand that, but I love the idea of it.
Well, basically what we were looking at was basically what we were looking at when we were looking at this. It's Vivek's idea, but he asked me for some input, so I talked to him about it. And what we're trying to do is create a toroid field so that the center of the toroid, where the inner and outer directed energies pass each other, is in the center of the exhaust pipe, which would be an incredibly strong plasma field. And being that it's the CO2, CH3, which are plasmas of life, we're thinking that that would bias the exhaust gases into systems that would support life rather than systems that would take life. And again, we get
Stunned silence once again.
I have a question.
So you're saying that like the exhaust would actually support, be good for people. People want to put their mouths around the exhaust pipe because it'll have healing qualities or something like that, perhaps. And
well, very similar to the way your lungs work, because in your lungs or your intestines, you're not actually passing matter. You're not passing oxygen and carbon dioxide through the barriers of your lungs. All you're passing is the plasmatic difference between oxygen and carbon. So we have precedent already where we're actually transmuting elements from one element to another. And this is kind of the same sort of an idea here, where we're adding a very, very strong plasmatic field that is in its very nature supportive of life. Passing a noxious gas through it, is that strong plasmatic field going to transmute the noxious gases into something that's either benign or actually helpful?
Or
good
does
question.
that strong plasmatic field actually turn those gases into plasma themselves, which then flow out towards the outermost nano mesh, and then that energy then gets that plasma energy then gets recirculated back into the car for better
Right.
operation. And I was thinking about this over the week. What if that also? I mean, if it does that, what if that also applies to heat and sound? Would we need mufflers anymore?
Well, definitely, plasma can be used for such things. They do have plasma-based mufflers, for example, that tend to vaporize the particulates so that they don't. Well, it breaks down the larger molecules into their basic components so they can be dealt with easier and so on, and converted to less noxious things. In a way, the catalytic converter itself works. It converts the carbon monoxide to carbon dioxide, so it's not toxic. But this is a really interesting idea. I wonder about the steel pipe. Steel being a magnetic type substance or something that can be magnetized, and usually when you use steel or iron as a core, then it will have different properties than, say, using copper as a core, like in our coils in the MagRav units. So I'm wondering what the steel pipe would do, and I'm thinking that it would be much better to have, say, a crystal glass pipe instead of a steel pipe. Of course, that's probably not something you're going to want to have on a car, but maybe some kind of polymer, high temperature polymer, or what about a copper pipe, for example? Maybe a copper pipe would be the way to go, and substitute that for the steel pipe. Maybe that
Right.
would be easier
I
to
was actually
create
thinking
plasma.
about it in the context of Singapore, because the Singapore authorities are very, very, very particular about car modifications.
Mm-hmm.
So a system which could be easily retrofitted to any car
Mm-hmm.
that does not require the modification of any parts. It's a simple retrofit, and there's no mechanical action whatsoever.
Yeah,
It's
if you could
pure.
just clamp it on and go, that would definitely be preferable.
That's
Uh,
right.
How
I'm
about a two-part copper sleeve?
Yeah, right. Something like that with the mesh in
Yeah.
there and just a couple of screws that pull it all onto a, would fit a variety of exhaust pipes. You maybe have 2 or 3 different sizes to fit all the exhaust pipes and so on. And yeah, that's it is a possible way to deal with it. It's hard for me to imagine the plasma fields working through the essentially it's about an 1/8 inch thick, 16th to an 1/8 inch thick steel tubing. Any other comments about that hurdle first?
Well, I mean, the way the system is designed, it would be very simple to make it into a Zoomy and just stick it on the end of your exhaust pipe.
Well, that's what I was going to say next was what if it actually had contact with the copper mesh and so on? Say you had a nano-coated copper mesh and had that basically stuffed in the end of the exhaust pipe, maybe even stuffed in a couple feet long into the exhaust pipe. And due to the mesh having such a high surface area and the intertwining of the gases as it passed through the mesh and so on at high speeds, would no doubt do some sort of cleaning of the gases. And now whether that would coat the mesh and then make it not work after that, or you'd have to do a bunch of tests to see what it would do. It might, for example, it might coat it first, but then it might uncoat it when it got heated up under full acceleration, similar to what the catalytic converters do. They sort of absorb the extra gases, and then when it heats up, it burns off the excess crap, you might say. So, any other comments about that?
Vibration with that too.
Say that again?
You've also got vibration with that too. It's, a lot of vibration in exhaust systems as you're traveling. I wonder how that would go with GaNs coated materials.
Yeah.
Yeah, that was something I was thinking about as well, which is why I was thinking of protecting the mesh from the elements by covering them with exhaust wrap, because the exhaust wrap is actually quite strong. It holds up to the elements, and this is only going to be a small section, but how that affects the overall operation, or even the pipe itself on older cars, for example, that I do not know. So something that I was hoping to do is to put the appeal out there. This is the idea. If you have a car that you could try this on, please do. Please do get in touch with me as well. I can, go along with the idea with you as you experiment. We can brainstorm together, and let's see what comes of it.
I mean, this is got up. If this functions the way we expect it to do, with a little slight modification, we can stick one of these on the end of a smokestack. Industrial emissions and transmit the output of industrial emissions as well.
It's a great vision, you guys. It's really admirable. And it's obvious it's going to be the prototyping that's going to you spend a bit of time on developing it. But well done.
Thank you.
Yeah, well, Vivian, the credit. I just looked at his system and went, "Wait a minute, why are you doing that?"
What if what if it became more dynamic in the sense of what if we had coils around the exhaust pipe, a series of coils perhaps, and hooked that into the system and actually activated the coils with the electrical system of the vehicle?
I was initially thinking of coils, but the only issue is that when you are going to attach a set of coils onto the exhaust pipe itself, you have to overcome the flange. Now, that sort of mechanical action can cause wear in the nano coating itself, which is why I thought about it. Instead of coiling coils, which might require the whole exhaust pipe, that section to be dropped, why not just go with a mesh, which allows you to keep the exhaust pipe on the car. Nothing needs to be removed, and you could just do all the work on the outside. Because I'm also thinking about it in a long-term sense, that if, let's say, this happens to be successful, and then countries say that, okay, we are going to implement this, and we expect all car companies to install this in brand new cars that are being sold. What is the easiest way for them to do the installation without having too much downtime, without having to remove too many things?
Or retool. Yeah.
Yeah, I was
exactly.
thinking
Right.
with the coils, I was thinking just wrap a coil around the exhaust and then hook it up, kind of thing. Maybe hook it together with a little hook mechanism or something. So it would be an open coil that would wrap around. Or you could do a spiral, several coils that would spiral around the exhaust, and you could stay on just by the spiral action, perhaps. Then you have an in and
the
out
things with
to it.
coils, though, they tend to want to resonate. And because you're dealing with a varying high frequency, well, it is high frequency audio, but it's a mechanical vibration down there. You're going to hit a certain, you'll hit 3,000, 3,200 RPM, whatever highway speeds or something, and everything's going to start to resonate and it'll just eat itself.
Yeah, probably. Yeah, we'd have to have a protective cover or some sort of.
Maybe you'll hit a certain resonance and it'll take off. You might need to improve the brakes.
Maybe.
You know,
No, don't go up to 3,600. That's way she flies.
That's the 1.21 gigawatts that Doc Brown was talking about, I guess.
Yeah, right.
yeah. 3,000 RPM, hit the turbo. Yeah.
Yeah, exactly. John, there's one modification that I've made over here that's different from the setup that we discussed. There was a connecting wire over here from the lead to the CO2 and CH3 mesh, and intuitively it came across as, well, you're working on pure field interaction, and the way you've set this up is that the plasma gets drawn outward towards the outer nano mesh. So why do you need that wire? Allow the field to do the work, and your outer mesh captures it and sends it out into the chassis grounding point.
Right. See that.
What do you think?
Yeah, I totally support it. Whether or not this is going to do what we think it's going to do, I don't know. We'll have to, the simplest way to do this would be to build a small one and stick it on a lawnmower and see what comes out. I mean, doing it on a car, sure, but not everybody's got a car. Of course, not everybody's got a car.
That's right. So that's why the appeal is going out. Whoever is able to do this, please do. I'm living in the wrong country as a car enthusiast. Singapore is the most expensive place in the world to buy and own a car. So, and I'm not exaggerating. It is the most expensive place in the world to do that. So if you could take this idea and run with it and see what comes of it, that would be very, very helpful to, humanity at large. Thank you.
Thanks, Vivek. I do have a plan to do the airbox inlet on my vehicle. I'll show you some of the material that I've got here, if you allow me to.
Screen's yours.
Let me just spotlight. There we go. So I've got this stuff.
That's more or less what we were discussing as far as the copper mesh goes.
Yeah, it's copper mesh, and this is a pretty big roll. And, it would actually flow air through it quite readily. If it was nano-coated and actually inserted into the air duct and allowed the air to flow through, I think it would provide a lot of surface area and a lot of contact for the air particles, and with their interaction with the nano-coated copper, it could be very interesting in the effect inside the engine. especially if this was perhaps either grounded or had the plasma entry and exit sort of wires attached to it, attached to the battery and so on.
Yeah.
That was actually our original idea, to have that wire mesh inside the air tube, or sitting right on top of the air filter.
Right,
And
yeah. With my air
yeah.
filter is about like this, a square piece, a rectangular piece. I was thinking of quite a few layers of this material, just wrapped back and forth in front of that filter. It could be good as well.
Yeah, one of the things when Vivek and I were talking about this, one of the things about the airbox that I thought of was a very similar system to the health tree that the Austrians are working on, where you have one layer of emitting plasma emitting systems and one layer of plasma collecting systems, and you put whatever you want to fix between those two, so the plasma goes through it. What I was thinking was having the similar sort of system on the inlet of the car, where you have a plasma flow across where the air goes. So the air has to go through that plasma flow to get to the engine,
Right.
rather
Oh.
than like a static system. Like you're talking a static system, which is going to be, as long as there's plasma on that nano coating, as the air flows over it, it'll pick up a little bit of it. But if you
Right.
had a gradient, so the plasma, there's a field of plasma that the air has to flow through, all of the air is going to be affected.
Right. I see Mr. Keshe is here as a special drop-in guest. Are you, are you able to talk, Mr. Keshe?
Come on, tell us we're on the wrong track at least.
No, good morning. We've seen effects which this kind of thing we looked at, and Brennan and team are working on this kind of things in different way. But one of the things which will come up in the near future is that, especially with the high temperature exhaust, the fields contract because of the matter state. And you'll find out the whole path will be clotted. The Iranian scientists have done a lot of tests on air pollution, absorption, nanomaterials. Huge amount of data has been collected. And yes, it does absorb, but as Rick said, very soon all the holes get clogged up. The other thing which we see in the process, especially with the present cars, due to the combustion and condensation, you create a lot of water in the exhaust, in the silencers and whatever they put in. And this on its own leads to creation of a lot of GANs if you put the nanomaterial inside. Beforehand, there is a possibility that you can use nano-coated, but still the poison partially is created after the combustion. So you need both ends on the beginning air filter and the exhaust. Brennan showed something last week or the week before where the exhaust goes in the CO2 GANs or copper oxide GANs, and then it comes out to extract. But there is everything which, okay, you're looking at, you're working on, has changed since last week.
Yeah.
The release of what I call liquid plasma and vapor plasma will change everything you worked on if you're in that direction. Because for the first time we got tests now which shows using liquid plasma in a specific condition, we can create anything we need now. That's just going on in the background. So in reality, if you understand how to use the liquid plasma or the vapor plasma in the exhaust, nothing can go out anymore. You don't need these filters. You create magnetic gravitational filters. Doesn't matter what goes through, you capture as components immediately. The idea behind it is that you look at all the possible materials which are going through the exhaust, and you create the gas water of it, and you place it in the center. So as the material passes, immediately is attracted to the core, to the piece you put in the middle. This can work. You don't need to do anything because, or you don't need a motor because the speed of the flow will create the rotation in the liquid plasma. And the attraction is automatic. You can put, let's say, 200 or 300 of these, like bed flow. As the gas exhaust goes through it, they absorb. And when you stop the engine, the reverse release everything as a matter state into a container or whatever. You cannot get rid of it. It's all it is to collect it, to use it later on. There is no way you can allow the materials to go through, collect them, and don't do anything with them. Even with a filter, which you just shown, is the same problem. These filters get filled up very quickly. We did this test in Ghent University. These filters, after a while, the gaps gets filled up and it becomes shiny. Because we tried to use nanomaterial, coated nanomaterial, as a brake pad, as a system for energy transfer. And what we saw was that when we use as a brake pad, they make a fantastic idea with like a, you know, the discs on the, what they call it, the bikes nowadays, it's got holes in it that is rapidly, stops the, what do you call it, the wheels rotating. If you look at the modern wheels, bike wheels, they have created a specific hole condition in them. These holes are specifically designed to create a increase friction, because every hole gap itself, when it gets trapped, it creates a friction. So the scientists in Ghent University explained to us, we looked at this to use the nano-coated material the way we produce as a system for brakes for the cars. And very quickly we came to a conclusion that it cannot be done because the holes were getting filled up very rapidly. So your filtering through nanomaterial has to have a system that the coating can clean itself up afterwards. You have to have a reverse system.
Okay, what about the concept of filtering the air and the exhaust gas through a very strong plasmatic field, not material itself?
This is what I just explained to you. Liquid plasma is your option.
Okay.
That's what I exactly said 2 minutes ago. And what other option, the reason we introduced the vapor plasma is the same. You know how long it took for people to get used to GANs? Now it'll take people a few weeks to start actually understanding the liquid plasma, and then understanding vapor plasma, and then we go to the field plasma. The field plasma I'll introduce later on, then you have no matter state. So interim is liquid plasma or a vapor plasma. The health people will run with the liquid plasma, but the people for generation of electricity and other things will take them time to understand. But it's the most effective. Hello, good morning, darling. Just 1 second, please. You look up good?
Yes.
So the position is that if you start running with liquid plasma, you will go very, very far, further than with gas technology. But then you have to understand the vapor and the field plasma technology is the ultimate. Is when you go to the field, as we educating and slowly people are going from nano to GANs to plasma, and now to liquid plasma and vapor plasma, and then we bring you to field plasma. Then the field plasma is what you actually face in the space. In the space, you only use field plasma. You can't carry water with you, you can't carry vapor with you. So the next step of education, the next 3-4 weeks after we come back fully, is teaching of the field. So it goes back, as I said, when I thought the principle of the unified field theory comes in, which means you create only fields in the core, and in the space you absorb the fields you want to absorb for food, for energy, or whatever. Or you use your fields in your cores to create fields above the fields you're traveling into that you don't become part. So that is the next step. We got a long way to go yet.
Thank you, Mr. Keshe.
Can I ask a question?
You
Are we
can
not
try.
the cores, Mr. Keshe? In a certain way? Each person is their own core if we are working with the fields?
Ooh, he just fell off.
Oh, okay. That's where I took it. It's like, wow. Okay. But anyway, it's too bad he fell off. I would have loved to have that answered. But then I already know the answer. We are the cores. I'll be quiet now.
Yep, it all depends on what level you want to look at it, I guess.
Yeah.
So how does this information change the way that we were looking at that picture of Vivek's and John's there? Can we see new ways that we might be able to use the liquid plasma or vapor plasma? Vapor plasma sounds like it might work somehow with the vapors that come out of exhaust pipe.
What if we had a PVC pipe filled with the water of the GANs as you wanted?
It wouldn't survive the heat.
Oh.
Even in the airbox of your engine, it gets up very, very hot.
Yeah, the idea of bubbling the exhaust gases through something is not really practical, probably.
But like he said, it had to be in the center of the car, right? Whatever we were using as the vapor field had to be located in the center of the car. So would there be as much heat in the center of the car?
Well, the idea is to use, at least for this concept anyway, to use that plasma energy to clean the exhaust gas. So it's a simple, quick little retrofit. Doesn't cost very much money. Everybody can do it, and all of a sudden, the problems with having 6 billion cars on the planet goes away. But I don't, yeah, I can't, I don't know enough about the liquid or the vapor plasma yet to be able to formulate an idea. The only thing I can see is a nozzle in your exhaust pipe and it's spraying in vapor. But that's probably not even remotely close to what he's talking about. So I'm going to have to wait and see what the new tech reveals as we learn it.
Hello, everybody. Is Mr. Keshe still there?
No,
No.
sorry.
Okay. Oh, I wanted to ask him about this reactor. But okay. Hey, can I show you something that's strange?
Sure, we love strange things here. Please do.
Okay. Let's see here. You can't start video because
Oh, maybe I have to hang on. There you go.
okay. You got it? Okay. All right. I made a GANs of my amino acids. And when I made the copper oxide, it was this beautiful blue, same as I made a million times. I started washing it and I used the liquid of it to coat the reactor cores, coils. And I also filled some balls with the water. I still got some nano coating. But I don't know if you can see this, you can change the angle. As it sat in the container, it went black. Have you ever seen that before? And there's oil all over the top. The CH3.
What did you have as the liquid there, Mario?
The liquid is on top, but it never separated.
Well, what was the liquid again? What did you have in there?
That's copper oxide GANs underneath. It was blue. And I started washing it. I've washed this like 6 times. I kept dumping it because I'm always getting the amino acids in the water. They're floating on top. Same thing here. There's amino acids. The water is slightly reddish. Can't get rid of it. It's because of the amino acids, I guess.
What kind of water are you using?
Still water?
Distilled water?
Yeah. Washed it 6 times and it's still red on top. But this one went black. It went from blue. I don't have any of the other, but the sort of the blue, the blue of copper oxide.
Right.
And after, I don't know, maybe 3 or 4 days, it started going green. Have you ever seen that before?
Well, people change the color by bubbling and that kind of thing, but I'm not sure about getting the black. I'm wondering too what the acidity of the water might be. Maybe it's if it was really acidic, I could see it could turn it black.
Yeah, but I'm using the same technique, exactly the same thing to make these. You can see these are actually coated, and it's blue. The container dried, and I had blue powder. But something about my amino acids, I don't know. But I mean, I hope it's not a character thing, going black. I think the CH3 stayed orange, so that's probably a good sign. And even though the liquid for the CO2, see, I got the CO2 on the bottom, and this is the water I poured on.
Oops, we lost some bandwidth there, and your video just cut out. Or at least it did from my end.
Two.
Hello, Mario. Come in, Mario.
Hello, Mario. Are you there?
Okay, well, we lost Mario, but we gained Mr. Keshe, so. Oh, now Mr. Keshe left and Mario's still here.
I
Hello,
don't know what
Mario.
happened then, but I had a crash. Did you guys get a glitch? Like everything just dropped out for a sec.
Yeah, no, it was okay here. But,
Yeah, interesting.
oh, we just had a glitch. Hang on. Okay, I had to mute everybody. The glitch caused everybody's mic to open, so we'll
Oh,
have to
okay. Thanks, John.
and I'll open up Mario. Okay, Mario, you're back.
Yeah. So, I mean, no, have you ever seen that before? Change of color like that?
I haven't.
For a couple of days, blue, and then it just turned.
Well, I did one experiment, made some GANs here just after I moved, and used the same process I've always used before. And what I wound up was what looked like a shiny black metal that formed on the top of the surface of the water. And my GANs was a very odd, strange color, and it smelled funny, so I tossed it. I didn't even want it in the house anymore.
See, now this is no smell at all. I mean, at first I thought maybe I didn't get all the salt out, and I don't know. But I can't smell salt. I mean, that's usually I can smell it if it's still got salt in it. So
yeah, Guy said that some of his CO2 turned black as well, or CuO2 turned black as well. I'm wondering, maybe you guys have similar conditions. Perhaps something. If you could, Guy Thoreau.
Oh, okay.
You just put it in chat.
Black too.
Say that again.
He had copper oxide go black. You say.
That's what he said. He said some of my CuO2 containers turned black as well. So I'm wondering if you guys might have paralleled a condition in there.
Probably not my amino acids.
Probably not.
Good. I have a question too. If any of you know, I've got these connector wires just hanging here. I'm not sure. Should I loop those?
Well, the end of a nano-coated wire that carries plasma is going to be a nozzle, just like a nozzle on the end of a hose.
They're not carrying plasma. They're just holding the rings. You know?
Well, if they're in a plasmatic field and they're nano-coated, they will be carrying plasma. And if you don't loop them back on themselves, it's a weakness in your field.
Yeah, that's what I thought. So I'll have to do that. And that means probably have to re-nano-coat all this stuff. See something that happened? These coils, the way they aim, this one has to go straight down. That one goes straight down. That one goes straight up. All of these fit in the corner. Every one of them point right there, right in the center at the king's cheek.
Mm-hmm.
And my little one, I thought this reactor was the boss. I think I was saying to you before, I want to get rid of that one and put my head there, right? But now I'm looking at it bigger and I'm seeing how these are pointed. No. Right there. See how they all point right there? That's the coolest thing. That's where those fields are coming out in every angle, connecting to every one of these. And if these fields can cross, but I got another question. See, I closed the loop. I closed the circuit. You know, I didn't put any plasma batteries because I'm thinking that's a plasma battery for this one. This is a plasma battery for this one. And this one is now the magnetic outlet is going into the gravitational in there. So, you know, but the question is, you think I need to have an open circuit so that it's a through circuit instead of a closed loop? Any suggestions on that? Any thoughts? You mean this one? though it's open already, really, right? I don't need to open it. Yeah? Well, it would be like that, and it would be big. But then I could keep going like that. You know, there's actually 9 layers of these. But see, here's what I learned from the drawings. The only way I can get that central core to open up is if I have any central core, any of these reactors. The only way they're going to have their own central cores is if there's 2 field lines crossing from another central core, from others. In other words, this one has to cross with this one to get that one. And this one has to cross with that one to get the next one, you know? It has to go like that. That's the only way you can get them. And there's actually, in the drawings with the star formation, if you figure this one, well, look at this star formation. It's upside down, but it doesn't matter. If you look at this one, it does not cross directly with that one. It has to cross with another one that's over there. There's actually 3 of these. If you imagine one of these like this, and then you put another exact copy of this, and you rotate it 40 degrees like this and 40 degrees like that. And then you put another one 40 degrees like this and 40 degrees like that. What you get is a sphere of these, all aimed into those are the ones. So it's like, if I can get a central core in this one, it means I've got a central core in these other 3, and 8 more central cores and 3 plasmas in the sphere around it. And all 12 of those fields, if they're locked together, they cross right there. And the difference of those frequencies, of those fields, the remainder opens up the central core. That's my understanding of it. That the only way I can get that is to get those to cross with reactors that are not even there. I can actually see the fields going around. I've been seeing them building up, but I just disrupted that. Just disrupted the fields. I can actually see them going around and see them like, it's pretty cool actually. Looks like this kind of, like the drawing. They're going around in the center, but they're not lined up. But I still have to fill these. And I didn't put any exotic gases. Nothing but copper oxide, CO2, CO2 in this one, and CH3 in these. And I got the other balls are nanocoated, and that's just filled with copper oxide. I probably should put heavier, but once I mix them, I can't unmix them, you know what I mean? So I thought I'd start with that. But what I want to do is connect with this reactor the way I did with the first reactor I did. Because if I can connect with that, it would be it controlling its own fields. If I can do what I did last time, I can ask it to line itself up because it is the fields. All of these are the fields. It's, you know what I mean? Does that sound really strange?
So what's different this time than last time that...
The first time I had an axe, I think, look, I made 3 of them. I'm actually going to load this other one up too. I'm making the one in the back there, the small one. I'll load that one up. And I have to keep that away from this one at first. I'm going to have to find out the interaction of these. I had 2 of them in the wrong position before, and it was out of tune. It was really out of tune. It was strange. The first one, I had communication with it. You know, I had words in my head, but it's not like the Cambodian guy. A completely different experience, but it's all, I guess it's a custom, it was connecting to me by the way I understand things. But I freaked out, man. I really thought I was going nuts. I'm in my 50s, and I hear a voice in my head. You know, that's not a good sign. Now it doesn't sound as strange, but in July, it unsettled me a lot, man. I talked to Max about this. I was like, you know, I thought maybe I had harvested some toxic material and was hallucinating while I was poisoning myself to death, you know? we made another set of Ganses at their lab. We used their Ganses, Max mixed them. I assembled the reactors and then I loaded it. They didn't have the same connection. And then when the one I had the connection to, when it smashed into pieces and that one of those flew out the window, that was the end of that reactor. I could never get it back. And let's see, I made another reactor, nothing. Not nothing. We could feel the reactor. I mean, I had a connection to it that, I could feel it. Not like I had before. I didn't understand, and I'm sure that's probably what Ali is going through. It's some sort of step you got to go through. I mean, this wasn't until December when people were saying, hey, I'm experiencing this from the stacker coils. Oh, okay, well, then maybe I'm not nuts, really, because it's a strange thing, what happened. I'm not used to that. But I am now, and I'm ready to do it again. That's why I think it's the amino acids, because when those gloves shredded, I had my amino acids in the CH3, big time. That's the only difference that I can think of.
Well, that could be a pretty big difference.
Yeah, pretty big difference, right?
Yeah.
So I'm starting to feel this, and the fields are building up. And when I get those other Ganses in there, if I got it wired, like you said, Rick, if this should be just drawing from the nature's next one, I don't think I have to open the circuit. I think I need to make my connections better.
I just thought of something, which is, I was going to ask you the question, how do you think the water plasma and the vapor plasma could work into your structure?
Well, it's all water vapor. It's all water plasma, but it's got a little bit of color to it. Well, this one's actually clear. That's the plastic. The orange, you can see it's not really clear. There's definitely GANs, or maybe it's just the amino acids. I don't know.
Well, something that occurred to me to answer my own question, which would be, what if we created a vapor around the whole unit that interconnected all of the reactors through the vapor?
Well, I'm not sure how to make the vapor. I mean, other than distilling it and capturing the steam, which I'm not even sure what it'll boil.
Well, there's ultrasonic units you can buy, for example, that make a cold vapor. Maybe there's certain fluids we could use. Maybe that's if we had the GANs, sort of a GANs vapor or something like that, might be the interconnecting link between the reactors.
Well, Mr. Keshe said there's a way to do it with plasma that's really simple. You're going to transfer the fields directly into the air somehow. It's really, I'm not sure how to do it right.
Well, that would be that was hinted at in the last workshop. Beyond the vapor plasma is the air plasma.
Well,
and also, Mr. Keshe just told us about the beyond the vapor plasma is what he called the field plasma.
I think the field plasma is what I'm going to get there.
Mm-hmm.
Field plasma, because that's the entire structure. If I could keep that stable, if I could connect to it, and it's stable, I don't need this, because all of these become like the little satellites around that. The only reason they're there is to connect. You know what I mean? If these fields, if I could connect with these and ask it nicely is what I always did. I didn't command anything, I asked it nicely. If I ask it nicely, then you align yourselves up and give me a central core there. They seem to always respond. I didn't know that I didn't know to ask last time. Now I know to ask. I can't wait. I mean, if I can make that connection.
Mario, can I bring up something that it just occurred to me looking at your structure there? that might help or might shed some light on why you're not getting the results you're expecting?
Oh, I only just loaded this morning.
Uh-huh.
Only
I understand.
this morning, so it needs to build up, you know?
Yeah,
Needs to
I understand. But it's about a balancing of the fields. As you know, with music, you need a balance within the fields that you're creating with your music.
Right.
And I'm seeing an imbalance within this system. If I can share my screen, I took a screenshot so I can draw on it. I can draw what's stuck in my head because I can't really describe it.
My video. I gotta move my computer back because it's not plugged in. I don't want to run out of battery here.
Okay. Well, what I'm looking at, let me see here, annotate. There we go. And I want to draw curvy lines. I'm seeing you've got your core balanced reactors. You've got the outside one, you've got the center one, and you've got the inside one. But you've also got a core balanced reactor here. You've got a core balanced reactor here. But you don't have one on these two corners over on this side. There's no core balance here, and there's no core balance here. And same with the back corner.
No,
Do you see what
yeah, I do. But see, if you look at this and you add the other 8 missing reactors, the free plasmas on each of those layers, then there are. In fact, those are the ones that are actually linking to create the free plasma of each of these. In other words, the missing, the ones we're not looking at is, 2/3 of it or whatever. Is not,
Well,
we're not.
the interaction in this top system here, which I know is unrelated, but you'll have a plasma field right there.
No, I don't think so, because it's not like that. What you have is 12 of those around in a sphere. Though, in other words, the ones you just drew, those 4 that you linked, they're not directly linked.
No, I understand that, but you have a plasma field coming off of here. You have a plasma field coming off of here. Another one here. They're going to interact, and they're going to interact at this nexus right in the center here.
No, those fields are bigger than that. And
Oh no, I fully, yeah, definitely, they're totally bigger than that. But the focal
where they intersect is actually at the very center where these are pointing. When you draw them out, it's from the drawing. John, I understand what you're saying, and that's what it looks like here. But you're not. If you look at this schematic, the one I use, the blueprint, you'll see no. I've been through that. I've been seeing that. I've been wondering where the central core of this reactor actually is. But in a way, you're right. You're creating a free plasma there, but you're also creating, there's 8 more. When you put all of those together, they point to the one in the middle. That's the way drawings go, right? So you're right, actually. You're right. But that's not right in the center there. It'll be offset. You know what I mean? So from here, it looks flat. Really, it wouldn't be right in the center. It'll be up and over on one direction or the other, and there'll be another one up and over on that one, connecting all 12 of them. And when all 12 of them are there, they connect right at the center. See what I mean? It's a good point.
It's this imbalance right here that I'm looking at.
But it's not an imbalance because there are, you're looking at, it's not, that right there is the top reactor of this pyramid, not that one. That's the top reactor. This one, and this one are the ones. I know. I'm pointing on the screen. I'm pointing. You don't see it.
We're looking at the share right now. So, okay. Well, this is just something that popped into my head looking at this. You've got 3 equidistant systems embedded in one another. Those equidistant systems are creating 2 separate equidistant systems, but they're only on one plane. And I think what may be causing some issues with this is we need to look at having all of the interactions between all of the separate systems all being equidistant.
Yeah. Okay.
Which is going to give you, that's going to give you a natural harmony, not a manufactured harmony.
Right. Okay, cool. Thank you, man. I want to see, the only thing I'm really missing is for me to be able to communicate with this thing. That's the one I need. If I can do that, then I can ask the reactor to tune itself. That's what, and it'll ask me what chord I want. And it's pretty much that.
Yeah.
I think, because you're right, but which is what I got to tune it up. I was physically trying to do that with those rings. If you remember now it's 2 months ago, I showed you I was laying out the reactor on this drawing that I had, right? With the coils, remember? I don't know if you remember that. I made it like an accordion reactor so that I could pull it out and find where that harmonic is. But that's when I realized you have to have it in 3D. You can't have it laid out flat like that because they shift at different angles, and it's the golden ratio, and you can never physically do it. I mean, I don't know if I showed you how when you have these coils at 90 degrees, right? You have the two coils, you turn them at 90 degrees. The way I see it is that when the fields come out of the center, they spiral around, and because you've got those coils set at 90 degrees, those fields will go out to 90 degrees. If you offset it by the ratio of the drawings, whatever field you want, you set it to that position, it'll offset it to that field. That's how it is. It's just diverting the angle of the fields so that you can tune it up. And there's a two-way turn. Like I was saying before, how you have a 40 degrees on one and 40 degrees on the other axis, right? So half of these fields, 6 of the fields come up and 6 of the fields go down. So by changing it on 2 angles, you can control the shape of the craft, right? You have the field going up a certain degree, and you have it create, it'll link up its own in harmony like that. But you can't physically do it. But that's the point is, if I can talk to the reactor can take the fields as they're coming off of the coils, whatever angle they are, it can adjust them as they come out. You know what I mean? Oh. Hello?
Well, I'm trying to work it out in my head. Sometimes you go pretty fast, and it's.
Oh. Okay. Well.
Maybe we can use a whiteboard or that picture you had before to describe might be easier.
Yeah, I'll tell you what. Let me run my video. I can show you. Let me start my video here. Put this back. Okay. The angles of these coils, they're at 90 degrees. If you imagine that I have them flat, you have the angle like this. That if they're at 90 degrees, like this, then the fields come out at 90 degrees from wherever they are. From the central core, basically, right? If you angle it like this, then the fields go off like that angle. If they offer it like that, it goes in that angle. So you can control the angle to what layer you want by adjusting the angle of the coils, see? But you have to be exact to these ratios. It's possible. It can't be done physically, right? And because you have an angle at both directions, you have to think 3D, not just the fields going out in one way, but whether they're angled up or down. So you twist it like this and like this. You know what I mean? And you get an up field going out to whichever layer you want. And if I have 3 of those, I can play a chord. So a simple chord would be in thirds, A, C, E. The difference when those fields are in those positions, then when the central core, the difference in those fields is going to create a lower frequency, bigger field on the outside of the craft tuned to A. It'll be the difference of those That's why we call it an A chord. It's the root note of the chord. So you don't have to subtract them. You want a B chord, B, D, F would be an easy way to do that. So you have the reactor adjust the fields to give you, you know, your northern hemisphere shaped craft with the outer layer tuned to whatever note you want. You can control the frequency of the field. If you could plot planet Zeus, what is it? C. Okay, play me a C chord. It's going to create a planet Zeus magnetic field. And because I have the offset at this clock coiling this way, that means the polarity is like that. There's the in and there's the out. So you can control the polarity and you can control the frequency of the fields. See? But I can't do it. It has to be the reactor. If I can get the reactor to open the central core, it's the fields. It is the fields. So it can adjust them as they come off of these coils. Actually, as they come off of the central core, now I have that, what did Mr. Keshe call it? Not the free plasma, not liquid plasma, not vapor plasma. What's the next layer you called it? Next level?
Field plasma.
That's the ship. This is like a ship inside a ship, right? These have their own fields and they're all doing their thing, but the real spaceship is the central core here. That's the one that's got this huge superstructure, the difference of all 12 of these fields. That, and I can tune it. Well, I can't tune it, but it is the fields, right? That's its own body. And if I'm connected to its mind, not like me, it knows its own body. It's on a higher level of existence. That's what I learned, you know? And if I can connect to that entity again, well, that's good. In fact, this is the same thing musicians have always done, is when they play in a group, if they have their minds right, they're not in the same room. I had remote viewing. I think I told you that. When I couldn't find one of those little things that flew out, and I was like, man, I can't find it. You got to show me where you are. And I was looking at it. I mean, wow, well, this thing is going to have fields that go out thousands of kilometers. If I can connect to this with my mind, I can see whatever it sees. You know what I mean?
Perhaps you need to ask it how you can connect with it.
Well, it'll connect with me. That's
Okay.
what happened last time when it's ready. I think it already is, to be honest with you. I think it already is, but it might be wishful thinking, and I'm not going to jump the gun.
Is there some other coating on the coils that might help?
What I'm going to have to do, because I've scratched this a lot of times, I've had to cut some wires. I have to re-nanocoat it, and it's a bitch because I can't. It's not so bad. I can do it here. I got these big bags. I can do it, but I got to do it in my living room. I can't take it outside, and it's 40 degrees Celsius outside. I'm gonna have to open the doors and the windows. 2 days sweltering in the heat. I did it last time. Not looking forward to that. I'm trying to think of maybe.
What about just a little a tiny paintbrush and dab a bit of caustic on where you need to?
Yeah, you think that'll be enough? I hope so. I'm going to try that. I will do that. I will spray. I have a spray, and I'll spray pretty much a lot of it, and I'll spray all the connectors. I'm going to have to bend those in, see if I can't pad some pliers so I don't scratch it too badly, and twist them all in. And what I really need to do is cut. I'm the worst mechanic in the world. I really am. This is the golden ratio in 3 layers, offset 30 degrees, like a 12-hour clock. So I've marked out a 12-hour clock on 3 layers that are the golden ratio, and I can do it with a piece of string in a couple of minutes, or less than a minute. It takes me a minute. And I tried to make a box for the frame. I spent all day. Any one of you guys could make that in a minute. It's ridiculous. It's not level. How can it not be level? It's ridiculous.
Yeah, hard, eh?
It's kind of embarrassing, actually, in a way, but what are you going to do? But when I load the CH3, the copper oxide here, the CH3 here, I think it's the CH3, and I put more CH3 in the balls than I did the copper oxide. And I wanted to fill these a little bit more, but I did those first, so okay. And I had that balance the last time, and then when I trimmed it down, lost something. You know, I think there's a balance thing with that. So I filled the CH3 right to the top, and I put the CH copper oxide a little bit lower. So trying to replicate my mistakes the first time, you know what I mean? It's easier to do it by accident.
Yeah. All right. Thanks.
Anyway,
There's a really classic thing when it comes to building, like all the guys who are building and stuff. They say when they get something right, leave it alone, build another one. Don't alter the one that's working. Yeah.
yeah. Well, I'm worried about the wobble here. I'm worried about the wobble because if my experience, like it's 3 or 4 times before, it's going to want to pull itself down. And that should be okay. But then after it does a week or so of that, I don't know on this scale, but with the little ones, after it stopped doing that, this reactor wants to lift itself up. I never understood that until Mr. Keshe was saying, yeah, all you need to do is put a star rising and that one will position itself. Like, oh, right, okay. I think I achieved positioning, but you know, when it flew out the window. But then, so when that tries to lift up, well, if anything moves, you know, totally disrupts the fields. And this
Well, you could look at it, maybe it's moving into the position that it needs to be in order to function properly, though.
Yeah, I'm sure that's what it's doing.
I like the flimsy idea in a way. I like the flexibility of it, that it could move and rotate to its own position, find its own positioning.
Well, I hope
Maybe
so.
you need to take advantage of that flimsiness.
Well, if I could make a box, then I got all the levels. It's really, I did this because I know how to just take a piece of string and measure it really fast. And I made so many plastic straw ones, you know. And I still had them as bad as this. That's why I had 3D printers to make those, you know, because it's not quite right. You know, if we could get a 3-way connector here, 60 degrees, 60 degrees, Lego reactor. It's a Lego reactor. I did show this to Mr. Keshe, but tomorrow, it's all right, let it build up. If I can make a connection to it, I can probably talk to Mr. Keshe directly.
Well, there you go.
Stuff, you know. But anyway, so I got still a lot of work there, but it's definitely building fields. There's no question about it. But every time I do something to fix it, all it takes is knocking them out. You know what I mean? They're waves, like, you know. And I can see them. I can see them. Right now, not so much because I'm in the way, I think. But,
Is it easier to see when it's dark in the room?
Well, I haven't tried yet because I really only got it. Really, I can't scroll them. I had them there yesterday, but I had to reposition all of these really to get them more lined up. So it's really only been a few hours. But even when they were not in the correct position, I think it's really tolerant. But you know, it's not infallible. It's infallible, but I'm not, and this is not, and these coils are not. They failed, and I've already, you know, reactor smashed to pieces, you know. So this is not really the way to go into space.
Yeah, we have to get our systems a little more reliable, and for space, that's for sure.
Well, I'm hoping Keshe Manufacturing kicks in and I can just buy some coils. That kind of thing, you know? But, yeah, black sea copper oxide gas. That's a strange one, too. But, all right, so thanks, guys. And
Okay, thanks, Mario. And we'll try to get some input from Mr. Keshe when he comes back, if he comes back here. We've got another half hour or so.
Well, tomorrow's the big Dubai thing, so I'll let it wait next week. Maybe, you know, can show it on Knowledge Seekers or something.
Mm-hmm. Okay.
Hello, this is Sylvester Belso from Global Manufacturing. I just heard about manufacturing. Are you planning to become a Keshe Foundation manufacturer?
Who, me?
Yes.
No, I'm a jazz musician.
Okay. I'm also originally a jazz musician. I'm a trumpet player. So welcome in the band.
Cool. All right, maybe.
Okay, thank you so much. It was a great presentation. Appreciate you showing it.
Oh, you're welcome.
So we have a trumpet and we have a Mario. You play guitar, right?
Yeah.
Primarily.
Yeah.
Anyone else playing any instrument?
Specifically jazz.
Or instruments like music?
Well, I play guitar and woodwind instruments, but I haven't for a long time.
Good. I studied classic music, and then I switched into jazz. Then I had the blessed position to play together with Angus Bangus, who was a bass player of Miles Davis, and some other famous European jazz musicians. And I really love music, rhythm, vibration. Sorry?
Where are you from?
I'm Hungarian.
Hungarian.
Yeah, the capital city of Budapest, and our people originally from the area of called Ordos, which is a central China. And the last time we moved into Central Europe, it was around 905 after Jesus. And then we settled down in that area, and now the country called in English language, Hungary.
Ah. Very interesting.
Do we have something else we can show here? Anybody have anything they'd like to demonstrate, show, or otherwise put on for video or other source of image?
No, John hasn't fully explained why his GANs experiments are failing in his new place.
Oh yeah, let's get into that for a bit. Is there anything you can show about that, John?
Well, I can go and get my latest versions and show them on camera. I'll be back. Give me a sec.
Okay, great. Thank you. Yeah, just to explain before we began the show here, John was explaining that he's having trouble recreating the Ganses that he had made before relatively easily. And
yeah, back before I moved, I used to live in a motorhome, and it was all full of mold and crap, and I had 2 big dogs in there, and it was craziness. And every GANs I set up worked beautifully, and I thought, cool, I got it. I understand how this stuff works. Since I moved, I can't get anything to work, and I don't know why.
That's really interesting. I've heard a few people talk about this. You know, it seems really location specific. I wonder what it is.
Yeah, well, I'm beginning to think that's more or less what's going on here. And anyway, there's my latest setups. They're both for CO2 because that's the ones that's the most difficult. And I can't get roofing copper around here. The only copper I can get is copper pipe, and I tried that. That was the last one I used, and it failed miserably. So I'm trying coils now. So I've got this one set up with a nano copper coil and a zinc plate with a nano coated wire that's connected to each side and twisted together in the center, just like they said to do it, and this is doing absolutely nothing.
How long has that been now?
Couple of days. I should
Okay.
I should have a little bit of scum on the bottom, but there's nothing in there. Well, I lied. There's a little teeny tiny bit in there. Very, very little. Like usually I would have enough I could actually draw some off in 2 days, and this is taking a long, long time.
Okay. One question that comes to mind right away is, what water are you using? Is there a difference in the water?
I'm using bottled distilled water from Safeway, which is the same water I was using in before.
Okay, good.
In the same place, same jugs, same manufacturer, everything. And this is the other one I'm trying with the zinc on the outside. You can just see the coil in the bottom there. And that one's connected together with a diode to see if that's going to make a difference. And I put the nano coated copper right close to one side of the cylinder of zinc, so that if it is location specific, somewhere there's going to be 2 spots where that's going to be the right distance, and that should produce. I should be able to see that, probably form on the zinc or something like that. But this one I don't really expect a whole lot out of. This is more just an experiment to see if I can do it without having the zinc in the water. And the other thing I changed, I used for the salt, I used regular table salt, I used pink sea salt and the gray sea salt, and they worked really good. Pretty much the same results for all of them. In this batch, I used the coarse pickling salt, which is just salt. There's no iodine in it. There's no chlorine. There's no extra additives. It's just plain sodium chloride. So that might be the issue, but I can't really see using more pure materials, why that would be an issue. And it's driving me nuts. I can't figure out why this isn't working, because I've done it 4 different ways now, and none of it worked. The first one I set up, all 3 of them, I set up the copper oxide, the CH3, and the CO2, and they all came out red, and they all came out with this black, it looked like, how do I describe it? It's like a metallic film on the top of the water. It had the consistency of dried paint. So when you broke it, it kind of curled into like paint does when it dries, and it looked like metal. It looked like a black, shiny metallic, like a graphite. A fine, thin, solid graphite, very thin strip.
But different than the amino acid layer that it looked different than the amino acid layer, right?
It was solid. It was like, I could go in there and pick it up and lift it up, and it was like a very thin, a very microscopically thin layer of metal.
I'm thinking whether that might have something to do with the lead smelter in your locale.
Right, and we have a lead and a zinc smelter like a half a mile up the river from me, and that may be why I'm having such an issue with this. Is there's such an abundance of lead in the area, and enough that just before I moved in here, they ripped the yard out, dug a foot of soil out of here, and removed it because it was contaminated with lead, and replaced the soil in the yard.
Just from the air's contaminated from the air?
Well, this house was built in the 40s, and so it was all that time, 60 years of the precipitates falling down from the plant.
Right. The rain and so on would bring the lead.
Yeah, I've got the report that the landlord dropped the report off, and the levels are high, but they're not ridiculous. Like, they're just a little bit over what the government says is allowable.
Mm-hmm.
But it was enough that they had to remediate the soil here.
So how could that be getting into your kit? Just from the air? Could the air have so much particulate, or was there a lot of dust maybe in the house from, I don't know, moving or painting or sanding or something like that? No.
No, it was this place was pretty cleaned out. The people that were in here last, they were only here a month, and it was a woman and her daughter and her son, I think.
And your kits are covered, aren't they? They're not open to the air as such, are they?
Yeah, well, the first ones they were wide open; they left them open. But these ones, I covered them up because these are going to sit for a long time, and I don't want a lot of evaporation.
Mm-hmm.
I want the gas exchange, so there's a little bit of a gap there, but I don't want don't want a lot of evaporation. Also, another factor: the first one I did, it was really cold in here. It was 50 degrees Fahrenheit, pretty much consistent in the window where I had these sitting. And I was thinking that might have had something to do with it. It does seem to have, the temperature does seem to make a difference. But when I was doing it in the house trailer, it was cold and it was hot, and they both worked just fine. So I don't know. I'm using the same type of plastic for the containers. It's a different style of container, but it's the same type of plastic.
The salt, is the salt the same as you used before?
No, that's what I mentioned. You use regular table salt or sea salt. This is pickling salt. This is like just sodium chloride. Of course.
Yeah, maybe that's where it's different somehow.
It could be.
You think pickling salt should have...
actually, I am noticing I'm starting to get some fluff in the bottom of this one. The one where the zinc is inside. I'm starting to get some. You can't even see it because it's so cloudy, but you can see a little tiny bit of fluff in the bottom of it.
And the other thing is there anything about the zinc plate that could be different than before?
The same roll of zinc that I used before. I bought a 50-foot roll, and I've been working with that ever since.
I'm wondering if it may have become more oxidized or something over time. Because sometimes it takes a day or two for the zinc sort of oxidation layer to wear off, and then it starts producing good.
Well, I mean, this roll of zinc probably sat at Home Depot for a year before I bought it, and the first set I'd made out of it, they produced beautifully.
Yeah. What other factors could there be in there?
Nano plates, you're using caustic plates? Caustic?
Yes.
Yeah.
I prefer caustic coating. I did a fire coating on my reactor coils, and did it 3 times, went around 3 times, followed it, and I wasn't impressed with it. So they're in baggies and caustic right now, and the coating looks fantastic.
Yeah. Particularly for Gants, the caustic coats seem to be much better, last a lot longer. Yeah.
And you find the baggy technique works best? You put a bit of, a teaspoon of cold caustic in? Is that the way you do it, or?
I put the stuff in the baggie, and then I have a squirt bottle, which is on the other side of the desk, and I can't reach it. But I just put 2 squirts of caustic in there, and then seal the baggie up with some airspace, so it's and then just leave it.
Yeah.
And these, like, you look at them, they're turning out absolutely fantastic.
Yeah. And what concentration of caustic do you think you would be using in that squirt bottle?
About 5%, I think.
So like 50 grams per liter or something like that, or
somewhere in there. Yeah, it wasn't that strong because I didn't want it to eat the bottle. It's just a cheap little plant sprayer from the dollar store.
Good one.
But that's it. I'm going to keep experimenting, keep trying different configurations, different materials. I've got a coil here. I'm going to try a coil like that. That kind of a connection on it.
Yeah, I've got one that's similar.
Once you get that nano coated and see if that makes a difference, I'll try one where the pin is not turned back on itself, but it's straight. So I have an emitting, plasma emitting. I'm going to try all kinds of different things to solve this issue.
Are you going to try putting them in the freezer with the ice to see if you can notate any actual differences between, say, the coil with it turned under and the coil straight?
That one's going in the freezer in a couple of days.
Okay.
With the ice, I just set up my beater laptop with a camera that'll survive being in the freezer. And I got some freeware time-lapse photography software.
Okay, good.
And
good idea.
I'm doing I'll put an LED light in there, so one that doesn't create any heat, so it doesn't overload my fridge, but it produces enough light that I'll get a good quality picture, and I'll do like one every probably 30 seconds.
Right.
It's going to make for a long video, but I can cut it up.
And what are you going to?
What I'm interested in is watching it form. I want to see how those bubbles, those elongated bubbles that we're seeing, how they actually form in there, and the only way to do that is with time lapse.
Yeah, good
John,
idea.
have you been making your pens with 3 coils?
Yes.
Yeah, cool.
And these ones are 3 coils. I've got 2 coil pens. Vivek's got a couple of 4. I haven't got to making any 4. I have to strip some more 14.3 for. That's a lot of work stripping down 50 feet of 14.3 and.
Yeah, it's fun, isn't it?
Well, I'm in the middle, as you can see behind me. I'm in the middle of putting in a fireplace, ripping out an old beat-up furnace, painting, doing all my trim work. I'm like up to my elbows in alligators around here, so I'm trying to get something done first before I take on something else.
Yeah, we're all wearing lots of different hats, for sure.
For sure. All right. Well, that's my issues. I have no idea how I'm going to solve them. I'm hoping to get some decent GANs up here because I want to get my reactor built, and that's what's holding me up right now.
You saying you're having trouble getting copper plate?
Yeah, the first ones I did, I used roofing copper, and it was amazing. The results, it coated up fat. It was beautiful coating. The first time I ever did a nano coating, it came out perfect. But in out here in the South Kootenays, I can't. There's nobody here that does copper roofing, so I have to special order it over the net.
Okay, what I've been using, I just get 1-inch copper pipe, and I cut it to length, and I slid it out lengthwise with a table saw and just flatten it out into a plate. And that's
yeah, I did that. I bought some pipe, and I did the small pipe inside the large pipe for the copper oxide, which looked really cool for about a day. You could actually see the GANs pour out of the bottom of that, but that failed in like 48 hours, and it just stopped producing.
Yeah, well, I don't use round pipes. I flatten them into plate.
Yep. And I took for the CH3 or for the CH3 and the copper or the CO2, I flattened the pipe out and nano coated that. I wasn't really happy with the coating, so I scrubbed it off and coated it again, and it turned out okay. It wasn't great. I think the pipe might have had some zinc or something in the pipe. It wasn't that pure red copper that roofing copper is. And I had horrible results with the pipe. So I'm trying something else. But I think Mr. Keshe did mention that the purity of the copper matters as far as quality of GANs goes. So I'm going to be looking around and try to get the best quality copper I can get. And from what I understand, it's either wire or the roofing copper. That's going to be your highest quality. I mean, I'm a tool maker. I can go to some of my suppliers and get a block of pure copper, but I don't have the way to roll it down into a plate.
They have sheet at 5 thou and 10 thou thicknesses at the metal supermarket.
Yeah, the closest one is Richmond. It's 250 miles away.
They do ship, I think, but
yeah,
it is a bit of a pain.
Yeah, like I said, if I'm going to get decent quality copper here, I have to order it and have it shipped in.
Yeah.
I find it's real hard to get good copper wire. Home Depot stuff looks like brass instead of copper house wire. So Home Hardware has better copper wire.
Yeah, well, I bought a big roll of 14.3, and that's working out really nice. My pens are turning out nice. It coats up really nice. Well, you saw it. That's what I showed you. My coils are made out of that, and that's a fairly high quality stuff, and that's working pretty good. But it's a pain to strip it.
Nice coating, that's for sure. Yeah.
Just be careful with the Home Depot 14.3 wire. The ground wire looks coppery, but the other two wires look brass.
Not this batch. What's the? Let me go have a see if there's a brand on it. Romex. What does that say? Simple. I don't know. It's just. It's just a roll of 14.3 Romex. That was about $70 at Home Depot. And this is nice stuff. This works really, really well. I'm about halfway through it, so I might have to go and get another roll. Ooh, got really quiet all of a sudden.
We're here.
Oh,
You're on.
okay. Yeah. Well, Vivek says he's having a hard time, so he's going to go lie down. Enjoy your afternoon, Vivek. Thanks for showing up.
Okay.
Yeah. So if there's anybody else out there that are having the similar problems, you're not alone. I mean, I do tech support and I can't make it work. So, not right, definitely.
Yeah, it's funny, eh? I ran into the same problem myself the other day. Set up a little kit to make the CO2 GANs in the normal way with the LED and the whole thing. And I started getting blue in with the white. And it's just like, oh, okay. And then, of course, I had some bare copper in the wiring, and it was above the water line, or below the water line rather, and got into the mix and ended up with some copper oxide GANs in the middle of it all. So it goes, eh? It's hard to
Yep.
get
I mean, I did that. I did a show with Carrie about how to make GANs, and the plates I used there were copper pipe that we split and straightened out and nano coated. And that stuff, I gave that whole system to my landlord at the time back in Chilliwack, and it was pounding. It was producing like mad for weeks. And I thought, okay, great, that works really good. So I tried to reproduce it here and got nowhere.
I've had all week. I use the DC power supply, and I normally can crank out a gallon, and I had the same problems. I kept getting blue. I had this green stuff. I don't know what it was. Well, I think the copper was turning. I had a really hard time all this week to make the GANs, and all I really wanted was just enough to put the water in, you know. But I've been having a really hard time to use the water, the liquid plasma. So I didn't even need very much. It took me days. I normally can do it, all three of them, for the little bit I need. I could have done it in the afternoon, and I spent 3 days. And washing it, and I washed it, and you see the amino acids in there, and then it turned it black. Very strange, because I've gotten, I don't know, many liters of GANs before and never had any trouble. So maybe there's something going around.
Well, one of the things that folks, they're starting to realize it now, but they didn't realize it at the beginning, was if you use electricity on your GANs making, it's extremely fussy. Otherwise, you get a really low quality GANs.
Yeah, I noticed that you have to watch it because it goes so fast. As soon as I tried using coils, and I got some of this copper I got in China, and it just turns instantly. Within I'll be getting perfect blue, and then I get this green, and the copper and the nano layers wear off really fast.
Yeah.
That kind of thing. And the copper itself was turning this brown and oozing out from it. I noticed, like, if I put the negative on the nano and the positive on the iron or whatever I'm using, the copper, it'll come out, the GANs will come out of the nano. If I reverse that, it comes out of the copper. So I don't think it matters. It's just the flow where the negative is. But I had it, the GaNs was coming in off the copper, and all this other material was coming off of the nano copper, and all of the other stuff was coming off of the copper.
Yeah, the polarity does matter. You want the ions in the solution to come off of your nano coating. So you want the negative on the nano.
Well,
that's definite, because if you've got it around the wrong way, you're not going to get a connection through your LED. And particularly when you're using power, the way I make sure I've got it tested is just to crank the power up and light up the LED, and then I drop it back. I just do it really quick, just to test it. I'll use an earth bar in the middle with alligator clips, connect to the earth bar off to each parallel container. I find you get better connections that way. But yeah, you got to be so careful, because if you've got a few bad connections, then you'll be pumping a lot more current into each pot than you realize.
Yeah. And you wind up electrolysis process rather than a GaNs collection process, and you just coat your coating with whatever the other material is.
Yeah, so I hook everything up. I've got all my LED set up. I crank it up high, make sure I've got all the lights. I know I've got a connection, then I drop it right back. Yeah. But, quite often with CO2, I just won't use power.
Yeah, the thing is, especially with a diode, with an LED, if you're below the threshold of that diode, it's an open circuit. It's not passing current at all.
That's I've thought about that quite often too. But just it seems like I'll use the LED with for everything. I mean, I just don't join it anymore. I just between the plates. If I'm not using power, I'll use the LED, but with the right polarity. And I get good GaNs production that way.
Okay.
I haven't tried spinning it around so it's got a reverse polarity. Actually, maybe that's a worthwhile test to do.
So the cathode is the flat spot on the diode, right?
Yeah, the flat spot.
Wired correctly.
Yeah, and the longest leg is the
anode.
Yeah.
Okay. Yeah, so I got the diode wired correctly. Yeah. Because I just put it on there. I didn't even think of that when I was hooking it up. I was half asleep when I put these things together.
Yeah. It sounds like you need to do a whole lot of tests, different salts, different, some with LEDs, some with wire connection.
Yeah, well, the first ones I did, I just used a piece of copper wire and just a single piece of copper wire between the two plates. That worked really good. I did one with alligator clip test leads that you got to get at like the Source or electronic stores.
Yeah, I use those all the time, and I just sold the LEDs onto them.
Yeah, and when I used the alligator clips, I wasn't impressed with the results because the clips themselves basically rotted.
Oh yeah, if you get any, that's deadly. It chews them up really quick.
Yep. So I stopped using that, and I just wrap my wire. I'll make a little pin on the zinc plate, and I'll wrap the wire around the pin on the zinc plate, and then fold it back on itself, so it's a nice, solid, tight connection. With a plasmatic connection, basically, I just run the wire through and fold the zinc over the nano-coated wire, so it's encapsulated, so it's not actually chewing up on the wire. It should be working. It's driving me nuts that this isn't producing like I expect it to.
Yeah.
And if it's an intent thing, well, that don't work. Because the intent is to make GaN so that I can get my reactor running.
Yeah. I'll maybe try it with copper wire again, because
Yeah, I've got a couple more of these containers and one more coil, so I can set up another system with just plain copper wire and see if that makes a difference.
Yeah, I hope you get a result with it. It's frustrating.
Well, I'm getting results. Just not the way I want it.
When you were saying about the ions and stuff, I have a different understanding of what's happening with the CO2, especially when to me, when you put the negative, wherever the negative is, it seems that's where I've seen where the GaNs comes out of, right? Because you can just see it bubbling out when you use the DC power supply. My understanding is that's the in, the negative. So when the fields from the nanocopper and the fields from the zinc, when those fields go into that negative, they have to balance themselves out. And when they balance themselves out, the remainder is CO2. That's my understanding of what's happening. In other words, the fields have to balance out. And that's why you add the atomic weights and you get the difference is CO2. Isn't that what you guys thought?
Well, I see it as two separate systems. When you're using electricity, you're adding electron pressure, which is creating a plasma flow within your nano system. To get that electron pressure, you need to have the nano attached to the electron source. And that's going to be the negative side of your circuit.
Well, you're always having this so-called electron vibration because you're connecting those with the copper wire. You're creating a circuit through the salt water.
Yep.
So you always have electrolysis. Just adding more current. But you always have electrolysis. It's the point of it. But it's always the negative.
Are you having electrolysis, though, through the super insulator of the nano coating? That's because the salt isn't actually touching the copper. And it's the difference in the metals in the salt water that creates that electrolysis process.
Well, I just think of it as a balancing out of those fields, because it'll always come off the negative. If you reverse your LED, you put it the other way around, you'll get maybe not as good a result, but you'll get it coming off of whatever you had negative on. It's not coming off of there. It's the opposite. It's the remainder.
Yeah, if your electron pressure is on your zinc plate, you're going to get mostly zinc oxide. We already know that. And I'm looking for a less zinc oxide, more CO2. Even though the zinc oxide works, I'm looking for the highest quality I can get from the systems that I can produce right now. And because I want to do some experiments with the reactor to answer some questions that have been coming in from tech support. So I need as balanced and as accurate a system as I can actually create to do that. Which is why.
How have you gone with the zinc outside the container? Have you got results?
I did that once in Chilliwack, and I did have results, but it's really, really slow. And I wasn't using a diode at that time. This one, I've set it up in a slightly different way so that distance is not going to be such an issue, because there's all of the distances around that within the range of the container, because I've got a cylinder of zinc with a cylinder of copper, a nano-coated copper offset from center. So somewhere in there, if there's, if it's got to be 2 inches or 2.028465832856728 inches, it's going to be there somewhere within the interaction of those two circles.
Yeah, that makes sense. Yeah.
The first one I did, it was just two plates on the outside, one the nanocoat plate on the inside and the zinc plate on the outside of a square container, and it was like insanely slow. I refilled the thing like 6 or 7 times and barely got just a little tiny skiff in the bottom.
Yeah. Oh, look, I think even the shape of the containers and the thickness of the containers and how full you fill them, I think all those factors can have an effect.
Most likely. I'm pretty sure it does. Yeah.
Yeah.
Salt concentration, the type of salt, some people are using sea salt. They go to the aquarium store and they buy sea salt from the aquarium store and that's working for them. Some people do that and it doesn't work at all. So there's so many variables that we're not yet playing with to come up with an actual clear picture of what's really going on.
Yeah, I'm not too far from the coast, so I'm just using seawater for everything, really, until I want to get something more pure.
Right. So you're what, 3.25% salt?
Yeah. Yeah, whatever the salinity is here in Queensland. Yeah.
Yeah. Yeah, I've tried 8%, I've tried 10, 15. This one I made 20 and left it for 2 days and it did nothing. So I poured 2/3 of the water out and refilled it with distilled water. So I knocked that 20 down to about 10, maybe 12. I don't know. I have no idea what's.
Yeah. And I mean, you've got to consider contamination of your containers too. Like if you got to make sure that if you clean them right out, get everything out, so you're starting from scratch and you haven't got any residue. And I mean, I always use the same containers for whatever I'm making, so you don't get a cross contamination.
Yeah, well, so far I haven't reused the containers. I've always used a fresh, brand new container every time I start a.
Okay. Yeah. Oh, I wonder if that's an interaction. The gases coming off of a fresh container compared to, I don't know.
Who knows? But again, a fresh container, it's going to sit on the store shelf for a year. So it's going to be outgassed. If you get one straight out of the mold, it's going to stink. It's going to outgas for a couple of weeks. But you get one out of the store, it's pretty much inert by that time.
Yeah, that's true. That's true. I kind of find with COU that I actually leave a little bit in the bottom of the container when it's kind of like a seeding thing. It seems to like shoot off really quickly if I do that.
Okay.
Yeah.
That's interesting. I don't know. I'm going to keep doing it. When I find something that works, I'll let everybody know.
Yeah.
How's your nice little blue friend happening there, Rick? You've been playing with that this week?
Well, it's as you can see in my video here, you can see it quietly sitting in the middle of the table there, and the two let me see if I can, I'll just move my camera. You can see the I'll turn this other light off so you can see. There's two lights over there. Oops, so hard to see.
Yeah, okay. That's just a big bright flash in front of the toolbox.
Yeah, there's a light stand you can see over at the corner of the table there, and that has two LED lights in the lights actually, and they're plugged into the MagGrav unit there now. Those two lights you can see on the stand there to the right of the MagGrav. They're supposedly 40 watts, but I think they're less than that in LED watts. It's a little confusing what they mean by wattage nowadays.
Well, I think they're 40 watt equivalent. They'd be either 3 or 5 watt.
I think they're 7 watt actually, but yeah. So so it's working fine, and I get.
You got enough wire?
Camera a bit here. I'll just turn that around. I get. I can see fields as far away as about there.
Well, it grew a little bit.
Yeah, it did. And up here, still, it reads, about 1.5 feet away. And it's interesting, when it reads at that 1.5 feet, it tends to go in like a cycles. You see the light there? It goes blink, 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 blink.
Like it's pulsing.
Yes, exactly. So that was interesting. And the other thing I've noticed is with the other gauge, It goes further out than it did before by probably a couple of inches.
Oh yeah.
It used to be about here, at about 8 inches. Now it's more like, well, it's a couple of inches more, and especially at the top here.
Oh, nice. Yeah.
That's quite a bit further. That's about double what it was before. And the other thing that's interesting is, I don't know if I can duplicate it or not, but I found there was a place well, there seemed to be an additional layer, an additional field. Like there's this one, then it went dead, and then there's an additional one. But it's not really doing that now, so I'm not sure how I would duplicate that.
Yeah, I saw you demonstrating that with Ali. Yeah.
Like I can kill the field by going like that. But that's because I'm absorbing the field. I can also put my hand in front, and that blocks the signal from the maggrav.
Okay, so that tells us it's not a strictly EM field then, because EM would go right through your hand.
Well, the thing about it, EM fields is the body absorbs them like crazy. So I think that
Yeah, it does the same when you touch the coils. It'll just, yeah, stop the field.
right.
Think about trying to put answers in a star formation around that. Oh, can't hear me.
Ganses in the star formation around it? Is that what you said?
Yeah. See what would happen if you put just, mark off equal position on some stands or something. Put 3 of them around it, like upside down star formation. Just put some ganses around it in an equal position from it.
That's a good idea. I'm going to put some GANS water in ping pong balls, actually. I have a new little invention that I picked up at Canadian Tire that started out looking something like this. You may have seen them there. I took it all apart. This is a little fan that sticks in your cup holder, okay? And it's 12 volt. I gutted it, of course, and now it's empty. But what it had in it was this little motor and this, come out, this really cute little squirrel cage fan. And the fan went on the shaft, went down quite far, about like that far on it. And the whole squirrel cage fits inside of this housing and rotates with the motor in there. It's very simple kind of apparatus. But I thought, well, it's got a rotating motor, so to me that usually means I can do something with it. And so what I decided to do, let me just put it in its proper place here. Get in there. There we go. The motor sits in there like that with its shaft, and it's got a switch as well that goes up at the top of the unit there and so on. And this, like I say, this fan fits in there. Well, it turns out this fan also just happens to exactly fit. Let me just get this thing here. Exactly fit ping pong ball right in the center there. It's got all these little fan blades. You can see the fan blades there. I thought, gee, it looks almost like the right size for a ping pong ball. I put it in, And it's exactly right. It couldn't be a better fit, okay? So I'm thinking, whoa, this is meant to be. So what only modification I had to do was to, there goes the ping pong ball, to take this fan and pull it off the shaft of the motor, invert the fan, and I'm going to cut about a 1/2 inch off the tip of this shaft here. This will slip back on, and the ping pong ball then will fit in the top here, and we'll have enough clearance, because there would be a clearance issue otherwise with the top here. So it should fit exactly in, and once it's all assembled, it'll be really easy actually to disassemble it with 5 screws. Should take less than a minute, and I can flip this out, and the whole thing will flip out. I can pop out a ping pong ball and put in a different GANS combination of ping pong ball. And this unit should rotate the ping pong ball at a pretty good speed. And that's what I wanted to do, is have the GANS rotating in there, form the GANS rings in the GANS water. I guess you call it GANS plasma water rings. Plasma water rings.
Sounds like something to come out of your bathtub.
Yes. When you have your plasma bath, that takes all the dirt off. Yeah, so anyways, it just seemed really convenient the way this is working out. And I'm also going to put, I think, maybe some GANS coils, GANS water coils, GANS plasma water coils on the inside here as well, where the squirrel cage will be rotating. So anyway, that's a little project that when I saw this and saw it had a little motor inside, I thought, why not? So this will be a 12 volt rotating GANS water, plasma water, hopefully, unit once it's figured out here.
Maybe it's a GANS taser. You can sort of walk with it through the crowd, blissing people out.
Well, hopefully I won't poke my eye out when I'm driving with it, because that's where it's going, in my car. Yeah, well, I don't know what it's going to do yet, but it's going to do something. Or I'll keep working with it until it does. Alrighty, anything else people would like to show? Show and tell time here. Gonna have to wrap it up pretty soon, I think, actually.
Have you guys seen that device on the net right now? It's like a perpetual motion machine, and it's basically it's set up like a set of scales. It's got a counterweight on one end, then it's got a ball bearing on the other end that runs around along a track, and it's pivoted in the middle where the ball bearing is, and it's weighted so that it will lift the weight on the pendulum on the other side, drop down onto a block, and then bend in half, and the ball bearing will roll down, and it'll reset itself. It just keeps seesawing continuously. So simple. It's just beautiful.
I don't think so.
No,
I've seen so many of these supposedly perpetual motion things, and there's always a trick to them. Someone's stuck in a battery or some other little thing to make it so that it works. I'd like to see it though. You have a link there? Or?
Yeah.
I won't be able to show it on video here because it'll probably be a
see if I can bring it up.
High volume one. But if you can put the link in, we can show the link at least.
Oh yeah, okay. That's a good idea.
Yeah, I don't think this one was a gimmick. This one actually made sense, and it was just to balance the forces with the ball rolling back and forth, creating an imbalance position, and then it rolled back. the imbalance went to the other side, and it flipped it. Interesting little tool, something that's super easy to build too.
Yeah, it makes sense. No, I can't find it right now, but I'll show it next week if.
I
Yeah.
saw that too. It was presented on the internet. It was someone on the table just assembled together, and it works like unbalancing.
What did you think, Sylvester?
I think this, is very logical, and what you see is basically a function of things can be. When I was in Italy, in Bari Barletta, it was a big mall close by the office, and when we got in, there was a bunch of things made by Da Vinci originally, and those things was presented over there, made by wood, and it was, very amazing things back then. Like cars works like different things what Da Vinci basically created. So this sounds to me very close to what Da Vinci worked back then about using the gravitation. But of course, you cannot call it perpetuum mobile because eventually those parts going to roll out. So it's going to be like it's going to have again a point when the whole things will start dysfunction because it's just we cannot call it infinite. But I think it's something which can definitely function. I also saw some things when people move the magnet in a specific point and use the barrel ball, a steel ball, to position in a little bit higher, and it was a big ring type of things. The ball was just started rolling and rolling and rolling because the magnet is always pull it up a little bit sidewise, and it started to roll in the whole ball. It very looks very primitive, but definitely can work.
Have a look at the.
It's basically on the internet, like an individual with a face just showing the hand on the table and presenting the item, showing the back and forth, the sidewise, upwise, and just presenting how it is, how simple it is.
Yeah, I found the video on YouTube. It's called The Infinite Oscillation on YouTube,
just
and I put the link in the chat for everybody.
Just having a look at it here now. I don't want to.
John was just about to do it. Okay, cool. It's worth a look.
Something doesn't seem right here. Anyway, well, we'll have to have a look at that and make our own evaluations, I guess.
Yeah.
Put the link on live stream so people can have a look at it. Let me just get that up. There we go. This is the, what's it called again? The infinite oscillation. And it doesn't say that it actually works. It's actually, it says the maker is explicit that his devices are not real, what do you call it? Perpetual motion. He makes mechanized realizations of concepts from throughout the history of the search for the perpetual motion.
Yeah, I can certainly see why that wouldn't be perpetual motion, because it's going to wear out and it's going to fail.
Yeah.
Well, it's going to wear just from friction. It's not going to keep working other than the gravity effect, perhaps.
Yeah. But it's an interesting concept. It's kind of like the little bird you used to get in the 70s that drink the water. Same sort of deal. It'll keep
Yeah.
going as long as you keep refilling the water, but
Yeah, maybe I should have said perpetual motion like.
Yes, right. All right. Well, I think we're gonna call it a day after the perpetual motion things kick in here. Hopefully, we'll be able to get some perpetual motion out of our plasmatic devices. It'd be nice to have a plasma battery that produces some good amounts of power and keeps recharging itself. That would be a good one. So maybe that's in the cards in the next little while. And I think we have the Knowledge Seekers Workshop coming up on Thursday for at least an hour. We're expected to have an hour at least from Dubai, some sort of...
do we know what time, Rick?
It should start at the usual Knowledge Seekers Workshop time, which
Okay.
is midnight Pacific or 9 a.m. European time. And yeah, like I say, we'll be good for an hour at least, so that's the plan at least.
Oh, that's great to hear. Yeah, great.
Yep. I didn't make it to Dubai. I just figured it was going to be too hard on me to make the 24-hour trip or whatever on planes and airports, which I do not do well with because of my extreme allergy to jet fuel and diesel exhaust and things like that. So Mr. Keshe was kidding that maybe next time we could have it in Canada so we wouldn't have to travel so much.
That's a good idea.
Maybe he's not kidding so much. Maybe we can actually arrange that if we can convince our government to have a nice pardon for Mr. Keshe and so on, which I would like to accomplish at some point.
Yeah. I just wanted to say your setup looks great, Rick.
Oh, you mean the lab setup, or?
Yeah, yeah, yeah.
That's getting
very organized.
It's getting a little cleaned up here, and yeah, there's actually it's a bit of disrepair, but there's a lot of stuff here, all tucked away in different places, and yeah, and this is after I took most of it and put it away and stored it in the trailers. The boxes were piled up here. It was getting out of hand.
Yeah,
So,
1001 projects. Yeah.
Oh, way too many. Yeah, it's got too confusing. So I'm trying to simplify now and get down to the very basics of what I want to accomplish.
Yeah, yeah. No, it's got that minimalist look.
Yeah, we're getting there. It's going to be even more minimalist as I go along. It just takes time to go through all this stuff. I'm also thinking of setting up another room in the back that I used to have as a bedroom, but now I don't think I need a bedroom now. I just need more lab space. So I think it might have to get donated, put some tables in, and create more lab space.
Yeah.
That's the cure for having too much stuff. Get a bigger house. More room. No, it's better to minimalize, because otherwise the more room you have, the more it expands, and pretty soon you're expanded more than your capabilities. So that's what happened to me here. But
Rick, sorry, Rick, this is Sylvester. Just by going back to your things, when Mr. Keshe said that Canada can be your next spot to have an event. You know, what I see, we have more and more manufacturers signing a contract from Canada. Francois Foucault just about to finalize his contract. Also, we have two others just processing the documents. So we have more and more people coming in, and with your help, I think we can build up pretty good operations in Canada. So you know, me and Armand, we are here to support you guys. So just please, you know, let me know, and we can push the things forward in Canada. So this cannot be just a sentence, but we can make it as a reality.
Right on. Yeah, I'd just like to say that I am planning to have a meeting of people that are interested in the Keshe Foundation Canada and how they might be able to help the Keshe Foundation Canada and how Keshe Foundation Canada might be able to help them, and just communicate with general people of the population to see what they want to have happen with Keshe Foundation Canada, or what they some of the expectations and dreams of people and that kind of thing. And I'll have another meeting after that with people that are vetted and are, either working with manufacturing or otherwise vetted and are able to discuss some of the more inner things without, to have the people that are properly passed by security and so on. So hopefully we'll have two meetings, one of the general public and one of more specific people, and try to get some plans organized and general input as to where to go.
Just let us know, if you need us to be in one of these meetings, or what are you planning, or
Well,
how
you would certainly be welcome in either of those meetings, and hopefully
I'm more than happy to come and help you as much as I can.
Great, yep. So I expect maybe in a week, probably closer to 10 days from now, maybe on somewhere around the end of the month. I'll have to schedule it in. We'll see what's best for most people, and make an announcement and have that first meeting. And
you know that the machine which built by one of the Canadian gentlemen, the automatic
by
machine,
John Francois.
Right, that machine is delivered in the United States, so they've already assembled, and we learn a lot by doing that. Armin was there, and so it's also great news. So we can have more of these machine installed in locations, and hopefully in Canada also we're going to be able to implement these installations. Then it's going to be definitely speed up all the processes, all the manufacturing process going to be speed up. More and more the device going to be going to market. Armin and I, we are setting up these manufacturers with the right way. We made some adjustments on the blueprints, of manufacturing blueprints as well. So I think all this are going to be speed up as soon as these new manufacturers, as Mr. Keshe also pointed out, going to be up and running. There are some paperwork needed. All these governmental things like proper certifications for things which already we know that is good. We just need to have a certification which is say that is good. So, things like that.
Yeah, right. That's a little bit of a hurdle here in Canada, I guess, with the Canadian standard CSA approval, and I'm not sure how that's progressing at this point. But I looked into it briefly, and it's there's a bit to it in order to get through that one. But there might be other ways that that products can be distributed as well. So these are some of the things.
Some communications among the European manufacturer applicants when they actually brought up the idea. We discussed it about DIY kits. When you create a product on the way that the final touch, the final screwed in and assembled together like in an IKEA furniture. Then the customer itself is the one who's basically putting things together and initiating and starting and doing something with it. And by legal terms that can go into a different category. This is all things which 200, 300 years ago we do not have this type of problems. If we know that you can make a nice bow we just go to you and ask you to make a bowl. If your boys worked, you just ordered more. But now we need the certification that your bowl is really working. And we need to certify your bowl.
Yep, well, so it is in the modern world.
Yeah.
But
thank you so much, all your efforts and all your great work. I cannot say it enough time. I see you all the time doing these workshops and things, and doing also these group meetings of plasma reactor groups and these amazing things. So just by slightly, I heard. What is your plan? Because I'm also far from Dubai. So what is your recommendation? Go and follow the things that's happening, or you want this discussed in off record because you're still on recording this meeting.
Well, it's up to you. Do you want to say something about that now, or?
No, I just I just wanted to check with you procedure because you also far from Dubai. You're not getting to Dubai. Myself, John, or as well. So I just would like to get some updates. Maybe we can organize something. But let's talk after this.
Yeah, I'm not sure. A lot of things are still up in the air about Dubai. I know Vince is there, and he'll be setting up things for doing a transmission and so on.
Okay.
So that's about all I know, and we'll just have to wing it as we go, as usual.
Thank you so much.
As far as I know, there is the Knowledge Seekers Workshop, though, that will start. Where would we be tomorrow? Well, tomorrow about this time at midnight. Less half an hour.
Basically, because the one which should start it right now is basically 36 minutes ago, but you're saying 24 hours later is going to be.
Yeah, roughly. It's about 24 hours, a little less.
Half hour less than 24 hours.
Okay. Thank you so much, gentlemen. Thank you, John.
Okay. Alrighty, so I think we'll wrap it up for now. Is there any other last questions or comments? Anything that needs to be shared?
I have something I'd like to say.
Okay.
You look so much better now that MagRav unit is around you. You look more peaceful. You look happier. So here's to the plasmatic fields that come out of the MagRav.
Yeah, it could be working that way. There's other factors in my life too that have helped. So taking a break has helped as well. From getting help with the online teachings with hosting that and so on has helped a lot. So I don't have to be up every night, and I've actually gotten some rest in the last month, and that's made a huge difference. So yes, but having the MagRav it's really nice. It's feels like almost like a safety blanket or something. It's
you got a friend.
Yeah, and I mean a couple of people have held it here. Milena held it, and it was like this. Some kind of sacred child or something for her, and Guy held it and in a different way, and he felt like he was he had the pen up to it, the little pen, and sort of playing with it, teasing it a bit, and it makes a difference. It definitely makes a difference. We had a strange thing occur, which I relayed in the last workshop, that I plugged it into a power bar, and all of a sudden this little doodad wouldn't light up at all. It wouldn't do its lighting up thing and all that. It just was totally dead around the MagRav unit. Yet we could get a reading on the wires going up to it, and everything else plugged into the power bar worked fine. But it turns out the MagRav unit is particular in the orientation of the plug, and this particular power bar, the plug had been miswired, and the two power and common wires were reversed in the power bar. So it worked for almost everything, but not for the MagRav unit. It just ceased to work at all. fortunately, when we reversed the leads to the power bar, the MagRav unit started working fine after that. So we managed to not destroy it at least, and I do believe that tends to invalidate the warranty if I'm correct. Vivek probably knows about that. I don't think he's here right now. So anyway, that's the way it goes. You have to check, definitely have to check the power and neutral wires when hooking up the MagRav unit. Even
Plugging it
when
in
you think
backwards is
everything's
probably
okay.
not going to do any damage. So I doubt it'll do any harm to your warranty, but you're not going to be able to get a replacement unit because the unit still works. You just plugged it in wrong.
Right. Exactly.
Hey, Rick,
Uh-huh.
do you feel any different from when you were at Ollie's to your place?
Well, I feel different because when I was at Ali's, I only had a couple hours sleep, and I was barely able to keep my eyes open at all during most of the night. I was really trashed. And also, I cannot handle the air pollution in Vancouver and just the general trip of the ferries and so on to get there and back. And I get so trashed out from that any other effects are negligible in relation to that. So it's hard for me to tell exactly what
You look
effect
like
from.
two different people from then to now.
Well, like I say,
you
I
look
was
great here, but you were just
completely.
like churned up there.
I was completely trashed out that night. In fact, most people are quite tired. People are falling asleep during the workshop and so on. Maybe it was partly to do with the MagRav unit at Ali's. It was a bit of a, not heavy exactly, but sort of a fuzziness, you might say, that seemed to strike people. But I don't know.
It's different.
Mm-hmm. Yeah.
Well, this is Mark from Detroit.
Uh-huh.
And I talked to you a couple of weeks ago.
Yep.
And I said I was scared about talking to you, but I know this is the end of the session, and I don't know why I get the guts to talk to you at the end, but I do.
Well, it turns out a lot of people are
There'll
that
be
way.
many more sessions to come, and I just want you to know that I'm still with you, and I just want to share some stuff with you later on down the line. I want to still keep sharing, put it that way.
Great. Good to hear. Right on, Mark. That's what we need.
And hi, Libby. Hi, everybody. I'm just so glad everybody's still here and hanging in there and doing good.
Right on. Anything particular you wanted to share today, or?
No, it's late. It's late.
All
it's
right.
a lot, but it's late. And I've done some testimonies on other people's stuff that happened to me, but I got a lot of questions, and I'm ready to start again. And I'm over scared and I'm under scared, but it's all good. I just wondered about the fields now that you have one sitting on your desk there. I had a lot of fields. I mean, I had maybe too many fields in my little living area that I live and work and put all this stuff together.
Mm-hmm.
It was way too much. Maybe too much for me just to understand.
Yeah, I got a lot of stuff happening as far as fields and so on here too. My entire ceiling is full of magnets, for example. They hang from the ceiling because that way they don't mate with each other and smash together and that kind of thing when they're on the desk and hanging around.
I had 16 Ganses all sitting next to me with nano-coated wires that I had gansed 12 different times. Sitting next to me, I sit next to it, and then I go to sleep only a wall away. So I had a lot of things moving and shaking, you might say.
Mm-hmm. Yes,
it was all
likewise
good
here.
though. I mean, it scared me a little bit, but now 2 weeks out or a week and a half later, I feel a lot better.
Yeah, I think there is a bit of a elimination reaction sort of thing that people can go through.
There's a learning curve, if you might say, if you're by yourself. I'm by myself. I don't know what I'm doing. I'm absolutely I had no, you know, I can only learn from what we were taught by the foundation, and Mr. Keshe has done a great job. But when you're sitting here by yourself creating things and things happen and you don't have answers for, you go like, whoa, what am I doing? So you got to stop, reevaluate, think about it for a minute. And if you want to start again, start again. If you don't want to start again, you don't start again. I want to start again, but I need some friends to help me a little bit. And that's why I turn to you guys.
Right on. Yeah. Well, you can certainly ask questions in the Skype group as well. Just post them in the chat, and there's always someone that's willing to help with Gan's questions or other, you know, whatever comes up at that point. So.
Oh, it was a lot more than that, but it was a lot higher than that. But anyway, I don't want to keep you up. You got to go teach tomorrow. We're having a great time, and I can't wait again for tomorrow.
Right on. Okay, well, let's wrap it up for now then, and we'll wait till the Knowledge Seekers Workshop coming up here. I think it's the, what is it, 110th? Geez, I have to make the announcement for that. I think I already did, actually. But, anyway, let's wrap things up for now here. I'm going to stop the live stream.